Hello everyone. Thank you very much for joining this webinar. Good morning to all of you joining from Europe, and good afternoon to those of you joining from Asia. It's our pleasure to have you here today. And my name is Emma Tracz, and I'm the Business Development Manager for the European market. I will be the speaker of today's webinar. And next to me is my colleague from the European sales team, Marcus Su.
Good morning, everyone. I'm Marcus.
And Marcus is going to help me operate the computer and to show you the live demo. So today topic is the Designer BLM mode. And after a short introduction of the product, we will show you the live demo of it, and at the end we will show you some results that you can achieve with our BLM mesh. We will also have Q&A sessions, so please stay tuned, and you can write your questions, take notes, and we will answer them at the end. So why our Designer BLM, and what is this tool? This is basically an embedded application, and it can be found in our Moldex3D Designer, and it provides auto and semi-auto meshing functions for generating the boundary layer mesh. I would like to get to the point now, and we will show you the demonstration. So you can see Marcus is showing you these two icons, the designer and the project. Those of you who use Moldex already know, and we will be using the designer interface now. After launching it, you can choose between the eDesign and the BLM mode. We chose the BLM mode, and you can see that it looks just like eDesign. We have the 5 steps on the right side, which we will follow. These are very straightforward wizards. We will import a file. As you can see from here, our BLM mode supports the 5 types: STEP, IGS, and Parasolid. And here we will import this part as the cavity, and this is the STEP file. So now you can see the part. It is a pretty complicated one, and we can see some red lines. We're going to run a quick check on the geometry to check what are the red lines, and we can see that there are the free edges and tiny edges. This problem needs to be fixed before we move on to step number 2, and there are 2 options to choose from. There's 2 options in CAD Doctor. We are going to use the CAD Doctor here. CAD Doctor is a third-party program developed by a Japanese company called Elysium, and at the end of October and in early November, we're going to have 3 webinars dedicated only to CAD Doctor. So if you are interested in this tool, please register for those webinars. Right now you can see we are in the CAD Doctor interface, and we did a quick check on the pad to determine what is wrong with it. We're going to use the 3-step tool that now Marcus is performing the auto stitch on the pad, and after the auto stitch there are still some problems, and we will run the last option, the auto heal option. Now the software finished fixing this part, and Marcus is using the final tool to fix it. It's called the Auto Flip. If you are interested in it, I strongly recommend to register for the CAD Doctor webinar. We will not introduce too much here about this. Now the part is healed, and we will export it back to our designer. The sound you just heard is from CAD Doctor. So now you can see that there are normal free edges and normal tiny edges, and we can move on to steps 2 and 3. And while Marcus is assigning the gate and the runners, I will just remind you that this is exactly the same what you do in the eDesign mode. You choose your gate, you assign the runner, you can change the parameters for all the features, and then you move on to step number 3, where you generate the mold base and the cooling channels, As well, here you can adjust anything you want for those parameters, and it takes absolutely no time whatsoever. So in step number 4, you can see that it's completely different, and this is all about generating the BLM. Here we have a few tools that we will follow. First is the modify node seeding, and the software will generate a default number of the mesh size according to the average thickness of the part, but we will make it a little bit smaller. And you can see that you can change the node numbers on any curve or any place you would like. So here Marcus changed the node number to make it more. And apart from this, you can also adjust the node numbers with two tools that I will use the slide to introduce to you. So these two options, they call curvature and proximity. The curvature, if you tick it, the software will automatically detect all the circular shapes and add 6 nodes on every circular shape to avoid square shapes or triangles. And the proximity tool will detect all the poor quality parts, narrow edges, like for example here, and will also add extra nodes on those places. So we already chose the node seeding for our part, and we can set the BLM parameters. We can choose the parameters for the cavity, part insert, runner, and cooling channels, and we can choose from different types of the mesh for 2 layers, 3 layers BLM, and we can also change the parameters for the runner and cooling channel. The final step will be to generate the solid mesh, generate the BLM, and you can see that there is a table where you choose which steps you want to run. We will run the first 4 steps. While the software is working, it is telling you which step is it now, and right now it's creating the surface mesh. If there is a problem with it, then it will automatically stop and take you to the fixed wizard. We have some problems with the surface mesh, and we're going to fix it. You can see that the software takes you automatically to the fixed wizard, and you can choose from many different options, many different tools. We will use the merge with tolerance tool, and if there are any overlapping elements, the software will delete them, and if there are any holes to fill, the software will also do it, and we will fix the quality, keeping the features of the part. And you can see that there are 2 elements left with full aspect ratio, and this will be fixed using the improved quality. And here we will not keep the features because these 2 elements are very small and they're not important for the part shape. We still have 4 little problems remaining. To fix those, Marcus is using the unfillet wizard. Here you can do it 1 by 1 fix, or just fix all of them at the same time. And now you can see from the table that everything is down to 0, and we can move on. You can see that the software will not go back and generate the surface mesh again. It will go straight into the auto-refined surface mesh. And while the software is working, you can see that the surface will be refined in those critical places. Like for example here, Marcus is zooming in the little dents and other features that need to be refined, like the circle and especially round shape. Now the software moved on to creating the solid mesh of the cavity, and this part is a pretty complicated one. It's got lots of different features, lots of angles, lots of round shapes, and it will take probably up to 1 minute, no longer. And you can see that the tool almost finished creating the BLM. So, Marcus, do we have to fix all the problems on the surface mesh?
For surface mesh, it's not necessary to fix all the problems, but you must make sure there's no cleavage, no overlap, and no the red bad elements.
Okay, thank you. The software returns to you a message that the quality of our BLM is too low and we have to fix it. And from the quality table, you can see the aspect ratio and skewness, orthogonality, and smoothness. All the numbers in red indicate the elements that need to be fixed. To fix them, we have two tools, the AutoFix and the Rebuild Solid Mesh. We will use the AutoFix first. Highlighted here, you can see all the elements that will be fixed with this tool. And this AutoFix tool is not very invasive. It will only move the nodes around. It will not. It will try to find the optimized position for the nodes. And the Rebuild Solid Mesh tool, as the opposite to the AutoFix, is a tool that will delete the existing bad elements and replace them with new ones, which means it will change the number of mesh. Right now, the bad element count went down to only 108, and we can use the Rebuild Solid Mesh for fixing those problems. So, Marcus, do we have to fix all the bad elements from the solid mesh?
If there's still some bad element, the calculation will be still no problem. But if you have too much, there might be some problem to the diverge. So here we suggest to fix at least the worst, the red solid element, become all the zero. No, this case of bad element.
Thank you. So now you can see already that the remaining bad elements, the number is 0, and the software is just finishing. So here we would like to show you another very cool feature from our software. Right now we're deleting the existing gate and the runner system, and we're going to replace it with another one somewhere else on the part. We are showing this because we want to let you know how easy it is to alter your design, to make changes, and the software will generate the new runner solid mesh, and we will also run the cooling channels in this one as well. So you can see that the software removes the refinement on the right side on the wall, and it will create a new refinement around the new gate, and it will generate the runner solid mesh and the cooling channels and also the mold base. Again, I would like to stress that this is also a semi-auto tool, and practically it generates the BLM with one click, and it takes much less time. While the software is working, you can also see the changes that are happening to the part. And the BLM is done, and here Marcus is using the chisel tool to show you inside the beautiful Tetra mesh and the prism layers as well, and you can see that it's a true 3D solid mesh for the part and the cooling channels and also the mold base. So the last step will be to save and export this part, and you can see that this took really no time at all. And in the next step, we would like to show you some results that you can achieve using our boundary layer mesh. So we will go to the other interface, to the project, and we will show you exactly the same part with the same runner design, which we prepared beforehand for the purpose of this webinar. So you can see the quality of the mesh, you can see how precise it is, and we will go to the filling analysis, and let's show the melt from time. You can see how the melted plastic fills in the cavity and how precise all the results are. From the packing stage, we will show you the volumetric shrinkage. Here Marcus is using the icy surface tool to show you where the part is most likely to shrink. And let's show the think mark displacement here. This is a cool tool, and you can see that the red elements indicate where the part might have the sink marks on the surface. And cooling. Cooling analysis, we will show you the temperature in the mold base. We will also use the slicing option, and you can see how exact the lines are for the temperature, and how the temperature is distributed in the whole mold base. And I think this is a very good opportunity to show you the total displacement from the workbench analysis. We will use a scale to exaggerate a little bit to give you more idea how the part will work. And we can see that this red bolt will work the most, but it will work inward, which means the part can be still assembled. It was great. So after this webinar, I will send you the recording of it and the presentation that I shared, just a few slides from it. You will have the time to check all of them. And thank you very much again. Have a nice day and stay in touch.